Multi-drug resistance has become a huge emerging issue over the past several years, and it's not very hard to see why, especially when you're considering complex diseases such as cancer or heart disease. A lot of the drugs that we have that should work to treat these diseases sometimes just don't. One of the reasons we've identified for this is a protein that's found in a lot of the major organs in your body. Your kidneys, your liver, your intestines, just to name a few. This protein, called P-glycoprotein, is responsible for identifying potentially toxic compounds inside of your cells and transporting them outside of your cells where they can't do any damage. The unfortunate side effect of this is that a lot of chemotherapeutic drugs are also acted on by this transporter and transported outside of the cells where they can't do their work. The solution to this seems simple. Either create drugs that are able to avoid being recognized by P-glycoprotein, or simply inactivate the transporter altogether. And in fact, if we knew the exact mechanism by which P-glycoprotein identified and transported as its substrates, this wouldn't be a complicated issue. But in fact, we do not quite know the current detailed mechanism by which P-glycoprotein transports, and that leaves us where a lot of great scientists have been before, in the lab. By making controlled genetic changes in the protein using a process called site-directed mutagenesis, we are able to probe structure-function relationships within the protein. With over 40 mutants created in the past 2 years, we've been able to elucidate stabilizing binding sites on the protein, as well as identify key amino acid residues in the transportation process. In addition, because I've been involved in this project for several years now, my level of responsibility and involvement has been able to grow. My confidence inside and outside of the laboratory has been able to flourish, and I've even been able to hand select several of the mutants that we've created in our lab. The trust that has been shown in me as the only undergraduate in my lab has been a blessing. But when I take a step back, it's incredible how much we've learned about P-glycoprotein, even though there's still so much more. Every mutant we make is laying the foundation for a new generation of pharmaceuticals to treat complex diseases more efficiently than ever before. Thank you.
Yeah.